Welcome to Project Geospatial. I'm your host, Adam Simmons, and this is Let's Talk Geo, where we interview unique individuals and amazing projects being worked on. In this segment, we have the pleasure of getting to know Kalev Litaro from GDELT, which is an initiative to construct a catalog of human societal scale behavior activity across the world into a single massive network. And that statement barely scratches the surface. Kalev, thank you for joining us. Can you tell us a little bit about yourself before we dive into learning more about GDELT?
Well, thanks for having me. It's great to be here. So yeah, my background, actually my undergrad actually is in computer science. My PhD was actually in information science. And that actually tells you something there. So, my undergrad was really, again, computer science is really about, what makes machines tick. It's about the machine itself. And my interest really is not so much with computers, but what we can accomplish with them, what we can do with them. What are the, especially one of the things to me, especially nowadays with the cloud is, if you had infinite computing power, what could you try to understand about the world around you? And, and that really kind of informs like my background and kind of the focus of my work, which has always been about how do we take, way back in 1995, I actually founded, my first startup was actually about creating web pages. This is in the very earliest days of the web when you wrote web pages by hand. Sold that off, moved into, into that area of how do we create websites? How do we kind of publish information? Then actually worked at the National Center for Supercomputing Applications, did a whole bunch of stuff there. I was actually doing a lot of virtual reality work. So again, this is the very early days. Again, from a virtual reality standpoint, not early days, but compared to today, very early days, worked in things like caves and immersive desks and, kind of these virtual worlds where you're surrounded by things. But then also looking at that point, really, we're doing a lot of work around how do we try to mine and understand the web at global scale? So essentially, how do you basically take the, sort of quote unquote, the internet, if you will, and try to understand about human society through that? So trying to essentially ingest what's available on the web and try to sift out the patterns of human society. And again, continuing that over the years, until present. And really, again, that underlying focus of my work is really this question of, all this fire hose of information that exists today in all of its many forms. And specifically, I think a key thing that I'll come back to in a little bit is this point that, we talk about, trying to understand the world. People think of that today as, born digital material. You plug an RSS feed into something and ingest that content and do something with it. But realize that across the world, for example, broadcast is really crucial, whether that's television or radio. Social media obviously is a big thing today. Print is still very crucial in a lot of parts of the world. And people tend to latch onto one of these mediums without realizing just how different of a perspective you get when you look across mediums, across the world and across languages. And, this is really, really crucial stuff that I'll come to is, this idea of looking globally. So if you think about sort of the focus of my work is really about, if computing power was infinite, what would it look like to try to understand planet Earth, whether that's the events that are occurring at every moment across the world, whether that's the narratives that undergird that, whether that's the emotion that those narratives and events convey. It's basically trying to understand what makes us tick as society. And once you do that, you can do all kinds of things, whether that's alerting to the next pandemic. And actually, as I'll come back to, my data was actually used to send one of the very first alerts of COVID-19 because of all the things I just talked about. On through today, it's used to track things like the locust pandemics. It's used to track government crackdowns across the world. It's used just this incredible data feed. But then also, again, one of my goals really is this idea of, how do we understand the lens through which we see? Very few of us have been to Syria recently. What we understand of what's happening there is through the news. What are all the things that are happening? So I do a daily series actually where I look at these things like, take the coup in Myanmar. How is that being covered across the world? Like who's talking about that? Who's not talking about that? Actually, amazingly, here in the United States, mainstream media barely mentioned that. It was like, yeah, there was a coup and, moving on to our other stories. But then also, how do we draw people's attention to what's happening around the world? So here in the US, I hear certain stories. I don't hear certain stories. How can how can machines help me if I'm interested and I want to? How can machines help draw my eye to all those myriad stories happening every day that I don't know about? And again, you'll notice an underlying theme of all of this is geography.
Absolutely. Now, so taking a step back here, when you were looking at it, when all these concepts were starting to come together in terms of curiosity and accumulating all this data from the internet, especially in the, we'll call it mid to late 90s, for example, when you start coming with these ideas, what did that look like back then? What kinds of data that kind of said, well, what can I do now from back then, before you even started a project like GDELT, what we haven't even started talking about yet?
Yeah, it's really fascinating how things have, changed. I mean, back then we were, using big supercomputers that were sitting, giant, these giant rooms full of supercomputers, versus today it's the cloud. Back then, you physically operated that hardware, which of course in the 90s and 2000s was, not a fun task, versus today, you don't really worry about that. But, in terms of data, so back then it was really, again, web crawling. It's basically, so for example, the work I did at NCSA, again, we're crawling the web. But, again, what was the quote unquote social media of that time period? So, take 2000, 2001, social media was Usenet groups. It was mailing lists, all these myriad mailing lists that were out there. It was, so it was kind of like, that was sort of social media of its time period. It was blogs. So essentially it was, obviously news media. It was the broader web. It was personal blogs. It was, topical, newsletters. It was all of that. And in terms of process, it was very similar, things like extracting out names, extracting out emotions, extracting out topics from this stuff. Trying to do what you could. Now, what was interesting, obviously, now early web imagery was not as, it was there, but it wasn't like it is today. And of course, video, hadn't yet really emerged yet. Versus today, and then of course, as social media rose, obviously things like MySpace and then Facebook, Twitter, all these things, this whole progression of things. And what's interesting about that in particular, today, when people talk about social media monitoring, they typically mean Twitter, because Facebook, obviously, most of the, most posts that happen on Facebook are private. They're not shared with the world. On Twitter, it's majority public. But one of the challenges with Twitter, for example, is, they don't publish. They stopped in July of 2013. So if you look at, basically from Twitter's founding, you see this exponential rise upward. And then around July of 2013 is when Twitter kind of froze. And that's when it kind of hit its peak for a while. And then the total tweets per day just decreased from there. And this became a very challenge. Now, of course, it's recovered, slowly leading up to the pandemic, very rapidly during the pandemic, but we don't have a lot of visibility. And Twitter is very limited in terms of, the demographics of who uses it, the types of things that are expressed there. Now, of interest, though, speaking of geography again, one of the challenges, when people think about mapping, social media, they think of these beautiful maps that people used to make from Twitter, where you can see, individual, roadways and everything. But what people forget is that was never supposed to occur. On Twitter, when Twitter first rolled out geotag tweets, people forget that you can say, I want to geotag my tweet, and you can say, I want to share my precise GPS location, or you can say, I don't want to share my precise location. I only want to share that I'm in Washington, D.C., period, without my location. Now, even if you said, do not share my GPS location, only share the city I'm in, behind the scenes, Twitter quietly included your GPS coordinates, even though you said not to, quietly included that in that data feed. And so that turns out that's actually where all these maps came from, was this geographic information that was never supposed to be. So in early 2015, there was a famous study where some researchers found you could take any random Twitter account that posts geotag tweets, and if you aggregate their tweets over a few weeks, you can find out where they live, where they work, the restaurants they go to, the gym they work out, what doctors they've seen. You can see all of that. And so Twitter then finally removed that. So
and I remember in the early 90s and even early 2000s, a lot of the mapping of the data didn't even come from the geotags necessarily from people's direct posts. It came from mapping IP addresses. It was a lot more open and bigger to do with that attached to information and defining the connection and correlation between the IPs and the people doing them, and much more deeper narrative between what's going on there.
Yes, and and one of the challenges, of course, with that nowadays is now that sites are hosted in the cloud, everyone has basically the same sets of IP address, the same geolocation. Geolocation has really disappeared now. When you do a whois lookup on a website, 9 times out of 10, or actually probably more now, you get domain privacy information. And what's interesting, again, like going back to geotag with Twitter, it used to be around 3% of tweets had a recoverable geotag on them. That's now down to a fraction of a fraction of a fraction of a fraction of a percent and falling each day. And so this is one of the challenges, like where does geography come from? So in our case, What we're specifically interested in is the geography of text. And so that's something called full text geocoding. And that's where most of my work in geography stems from, is taking an article. So, take an article about, say a quarantine order, and understanding, obviously going through that text, understanding what's a location reference, what's not. And that's actually a very difficult problem. One of the interesting challenges here is that there's not a lot of good work in full text geocoding. There's a lot of these attempts. The classic one someone does is they build something that does capital names and country names. But then you have this wonderful article. It says, Georgian lawmakers today passed a new law. Was that Georgia the U.S. state or Georgia the country in Europe? So that, fails over pretty quickly. You obviously have the famous examples, Paris, Illinois, Paris, France. You have disambiguation. So one of the papers I did a number of years ago actually looked at the namespace conflict. And that's something that it's interesting that so few people in the geocoding space really have appreciated the importance of that. So namespace conflict is, take the location of Paris. How many Parises are there in the world? How many are there in the United States? So for example, if I say Paris, France, probably almost all mentions of that are probably going to be the Paris that we think of, the capital. That's not always the case in a lot of countries, and especially once you move below those super locations. And so this becomes a really interesting question, because if you have a country where every location in that country, there's only one location in that country with that name, you basically have no namespace conflict. So if I give you a location name in that country, what it is, a one-to-one correspondence. In the real world, that varies dramatically. Some countries like the Vatican actually does have almost a one-to-one correspondence. Other countries, the overlap ratio is incredibly, incredibly high. The higher that is, the more you're having to lean on contextual cues to understand which Paris, or like Champagne, which Champagne is this? The Champagne, Illinois, Champagne, Ohio. And especially when you look internationally. So when the LED celebrated its 50th anniversary, one of the major Egyptian newspapers referenced Champagne, United States, where the LED was created. Because to them, there's only one Champagne. In reality, how do you deal with that? So again, and there's lots of approaches, so many approaches that have been presented in the literature. The problem is that most of those actually don't work in the real world. So on Twitter, for example, the classic algorithm a lot of people have proposed is to say, here's an account without a known location. What accounts does it interact with the most? So the idea would be, here's an unknown account. It interacts mostly with people in Champaign, Illinois. I'm going to guess that it's also a Champaign, Illinois account. Turns out that doesn't actually work, because on Twitter as a broadcast medium, we talk to people near us half the time. We talk to people on the other end of the globe half the time. And near is a very broad sense of things. So it turns out a lot of these things, they work great in laboratories and academic papers, but when you work globally, they really flop. And especially when you're trying to look at local locations. So for us, an article might say that there was the police shot protesters in a small local village. Assuming that we have a gazetteer that can give us that, it's really, you're really, really leaning on contextual cues to try to disambiguate that. So geocoding, so in our particular case, we use full text geocoding, but we've, invested relentlessly on this. It's an incredibly difficult problem. We've really not seen any tools that do this well globally, robustly, and especially at the local level. And that's before you talk about things like multilingual geocoding. So we started this in 2000, when we started multilingual geocoding. So before we only looked at English, in 2015, when we started doing multilingual geocoding, it's a huge, vast area of research in the NLP community. But only a handful of languages were supported for that. You didn't see geocoders that could work over tens or hundreds of languages. And so in our particular case, a lot of that work has been around how do you geocode at global scale? So we monitor 150, the GEOLT project monitors 152 languages. We machine translate 65 of those. And for those 65 languages, we do full geocoding across that down to the level of a small village. And so this becomes a very interesting challenge of, how do you, now again, textual references, they're centroid based. So a reference to Paris, there is no dot in a map for Paris. So, how do I deal with the fact that from a textual standpoint, I might see a reference to Paris. If I'm overlaying this, say, against satellite imagery, I'm going to have obviously much more precise coordinates. How do you kind of, deal with those issues? How do you draw a bounding box around if you need to offer some kind of bounding for Paris? And this becomes really, really interesting in the case of news media, because a lot of people use Western news media because they use English language Western media to understand the world. Here comes a great example: the March to Mosul. There was a study at one point done with our data that showed that for the March to Mosul, again, one of the interesting things there was a major data set that was widely used did not align well with our data. And upon closer examination, it turns out because they were using only major U.S. sources, major U.S. newspapers assume very few people know anything about the geography outside the United States. So anything to do with Mosul was just Mosul. In our case, we were coding down to all those local locations. So we actually showed that progression forward. And this becomes a really, really interesting thing when we look at, what it means to use textual geography. And this is also, I should add, things like Wikipedia, where Wikipedia has textual references, but you can also hand encode latitude, longitude. So there's been some famous studies of Wikipedia that have said, gee, Wikipedia only has locations in a few parts of the world. That's true for the latitude, longitude. But if you look at the textual references there, because again, very few people that contribute to Wikipedia actually go into source code mode and then add in, the actual syntax that Wikipedia has.
For every single word that they reference in there, it's tedious. I'll give them that. It definitely is a tedious thing.
And so, again, like adding that, whereas this geography is really like textual geography is really how we express our sense of space. So again, that balance there. So for us, really geography is primarily in the form of textual references to space. Although for imagery, we do use Google's Cloud Vision, which I'll come to, that actually does try to estimate the location. So if it's seen this location before, it will place it down a coordinate. And I'll come back to that.
Well, let's hold off on that. I actually a lot of questions that came out of just all that, but let's take a step back. Let's talk about, because we're already into the conversation deeply now. Let's talk about what GDELT exactly is. I overshadowed it with a brief sentence for an introduction. So tell me what it is, how it got started, and then let's get right back into some of the weeds, because I think that's very interesting stuff that you're talking about right now.
Yeah, so the idea of the GDELT project is basically a global open data data set, basically cataloging planet Earth. So exclusive right now, primarily through news media. So I do a lot of studies on social, and you'll actually see that in the GDELT's blog, where we've mapped out the history of Twitter, we've looked at the geography of books, we've looked at all these different things. And actually, geography of books is really interesting when you use textual geocoding going backwards through time. Of course, if you go too far back, you have all these fascinating things of locations that don't exist in modern gazetteers and the whole world on that. But as long as you stay within kind of the modern era, it's really interesting because you can actually see these waves of publishing as, kind of the focus, especially of American books, kind of pivots around the world. You can see fascinating things there. But yeah, so the GDELT project is really about this open data. It's essentially, if we could take the world's news media and process that in real time, what can we understand about planet Earth? And that spans many different things. It spans languages and geography. So we try to collect media from all countries of the world. Languages, we monitor 152. We process actually what we can do in native languages, we do in 152 languages. For 65, we machine translate them, and we can do even more there. And then also modalities. So again, online, print, broadcast, and broadcast is television and radio. So we look across those different modalities, and we do many different things with that. So we try to catalog physical events around the world. We look at narratives, we look at emotions, we look at visual portrayals. For emotions, we catalog between 2,000 and 4,000 emotions per article. So you can, for example, look at things like primal anxiety or, fear of the future, moral call-outs, power referentials. You can do all these fascinating things in there. And so the GDELT project, you can imagine essentially is this massive fire hose of annotations where essentially we're monitoring the world's media in real time and generating these annotations saying, a protest is being reported here. 10 minutes later, it's being reported that the police are firing upon protesters. What are the locations that are being ascribed? What details are being reported? And then, is how are media reporting across this? And so it's essentially this annotation, basically. It's as if you had basically a huge, room full of humans sitting there tapping out what's happening, how they're being framed, the narratives. That's essentially the data. It's all open data. It's all available, open, free and open data to really help. And there's within that so many different sub data sets that really allow you, you can take a word, for example, and plot out the geography of a word. Like we actually have a data set. You can take like the word blue and see, what are the locations that are mentioned most often in the context of the word blue. So you can actually, I did a blog post on this. It's really fascinating. Ordinary words have really interesting geographies ascribed to them. simply because of how we use these words to talk about the world. And so it's very interesting. You see how like ordinary words, like even like colors, can have these very strong geographic affinities to them. So again, the sort of the hidden geographies of language.
Excellent. Now, two questions that come out. How far back does your historical archives go? Let's start with that one. And then, and then kind of two, branching out to, well, let's start with that first question.
So GDELT's data, the extended data sets go back to 1800, so that's through books. Starting in the kind of mid 60s, we switch over to kind of early digital news. And then starting late 70s, early 80s, that's really when that's when most newsrooms went digital. So then digital news, again, very limited though, more to the US. And then again, year by year, more and more digital news is accessible. And then of course, with the rise of the web, especially kind of the early 2000s when there was kind of this late, kind of mid 90s, accelerates. And then early 2000s, really when web news exploded, which allows us to really reach across to the rest of the world. So kind of this explosion outward. So kind of 1800 for the earliest data sets, kind of the 60s, 70s, 80s, 90s accelerate, 2000s accelerate. And then collaboration with the Internet Archive, actually, we've done a lot of analysis on television news. Their archive begins in 2009. They now have a radio archive in 2016. We're looking at that as well. Television news, we've actually done some fascinating maps where we've actually gone through the transcript, CNN, MSNBC, Fox News, their closed captioning and actually doing these geography. We can actually make these maps. We actually have made a series of maps that actually show the geography of television news. And actually in 2016, we compared, we took a year of television news and we looked, or it was actually a couple years of television news. And we looked at all the locations, how often every country on Earth or a location within that country was mentioned. So you have this map, this nice chloropleth. And we compared that against US-based Google News or Google's US-based Google searches about all those countries. The two were flawlessly correlated. Now, we don't know which drives which. We can't tell you that the news media talks about this country and doesn't talk about this country. So that causes, that drives search interest. Or is it conversely? We don't know that, but we can tell you that media coverage and search interest are perfectly correlated geographically. So that has these really, really fascinating things. So yeah, so it's sort of this extended, and obviously the further you get to present, the more and more content is simply accessible.
Now, do you extend media into audio radio stations as well?
So in collaboration with the Internet Archive,
because I'm thinking of like things like unique geographic stuff like Radio Garden, for example. That was really impressive. Someone mapping out all the radio stations globally. You can listen to any single one of them, right? So, but just auto transcripting all the stations from there and just cataloging what's going on locally, that would be impressive.
Yeah, so the Internet Archive, so they have something called the Television News Archive that runs 2009 to present. All said and done, they've monitored about 150 or so stations, or somewhere around that range over time. Again, usually it's like they'll monitor they'll monitor a couple stations, and then they've done a lot of experimentation over time. They have a set of stations: CNN, MSNBC, Fox News. They have like the evening news broadcast, ABC, CBS, NBC. They have like BBC News, which is actually collected in London. So you actually have the London version of it versus sort of the American version. Al Jazeera, DW, RT, a lot of different stations. And so for those, they have the closed captioning of those. So we can go through the closed captioning and see what geographies are mentioned there. We also, since the start of last year, have actually been having Google's video API actually watch CNN, MSNBC, Fox News, and BBC and the evening news broadcast every single day, 24 hours a day. And we actually have the evening, we've had it watched back a decade. So there we can actually do really interesting things. We can not just see what locations were spoken, but we can see what locations appear in the on-screen text. So we can do some really interesting things there. For radio, there's something called the Internet Archive's Radio News Archive. Now that all said and done, I think is about 500 or so stations, but most of those are brief windows. Like they'll monitor a station for a couple of weeks to get a sample of what it looks like. The continuous stations that they've monitored over the entire window is a smaller set, maybe a dozen or two. And there they use automatic speech recognition to recognize those. And these are exactly the type of things we're starting to look at is, how often is a particular location mentioned? And be able to look at these really interesting things like how does television compare with radio, compared with online? We actually did some experiments with COVID where we actually compared. So for radio, like in the case of the UK, you have BBC Radio FM4, which is for a domestic audience. You have BBC World Service, which is for an international audience. You have BBC News London, which is again domestic television, and you see these really interesting differences in how quickly they covered COVID, how quickly they pivot away from COVID, how much airtime they focused on it. So you start seeing these really interesting differentials there.
Excellent. So just to kind of, how has GDELT evolved since its inception? What kinds of technologies has helped you grow it, or say, oh, we can do this now, that type of thing?
Yeah, so GDELT's just grown leaps and leaps and leaps and bounds, and it's really, and especially it started monitoring events and the narratives and emotions. We've really just expanded, again as more and more of the community, especially working now with journalists who are very, very interested in things like media framing, what's being covered, what's not being covered. Language is a huge thing. So prior to December of 2015, so actually, here's a fascinating story. Speaking of geography, so in the aftermath of the Ebola outbreak, of the 2014 Ebola outbreak, we went back and we had actually monitored through a local broadcasting partner. We had actually monitored local radio broadcasts in the forestry region of Guinea that actually alluded to this disease outbreak of unknown origins. And again, they didn't come out and say the word Ebola because they didn't know it was Ebola at that point. But based on what they were describing, it was basically Ebola or Lassa fever. I mean, there weren't many options, and whatever it was really, really bad. But that was in French. In the time period, we had just started experimenting with machine translation, but we weren't translating that much. So in the aftermath, we realized, wow, had we been doing machine translation, we would have picked up the very earliest glimmers of this. This led to a huge initiative talking to a lot of folks, and the answer was, look, you can't do machine translation at these scales. It just can't be done. Well, again, enter the cloud. The clouds are very, the cloud is the cloud truly is magical. It's as close as you're ever going to get to computing power is infinite. So it turns out you can translate absolutely everything you monitor in the cloud. For us, we monitor 152 languages. We translate 65. That's actually increasing steadily now, or will be very shortly. And so for those 65 translated materials, 65 translated languages, we translate absolutely everything that we monitor in those 65 languages. So fast forward to December of 2019. There's a company up in Canada called Blue Dot, and they're a biosurveillance company. They work with groups from the WHO, all these different groups. So they take our all of our data sets are open data, and they built their own machine learning models that take, so one of our data sets is called the Global Knowledge Graph. The Global Knowledge Graph is essentially a metadata annotation data set. Each row is an article. So it'll say, here's an article, URL, and then, here are the topics we saw in it, the organizations we saw in it, the locations we saw in it, the emotions that we saw in it, basically any, kind of things that we could understand about that article. So fast forward to December 2019. On December 30th, we monitored local news coverage in Wuhan, China, in Chinese. And because of our machine translation, again, nobody was looking for a pandemic in Wuhan at that moment in time. But again, because we translate absolutely everything, that's a big thing. Most machine translation, they focus on, I'm going to translate on demand. I know this is interesting, so I'm going to translate it. For us, again, that you miss everything. So for us, we translate absolutely everything that we monitor in those 65 languages. So again, Chinese is one of those 65 languages we look at. So we translate this set of articles and output that. Now, their machine learning models flagged that. So this came out December 30th. Their machine learning models flagged that and said, hey, based on these annotations, this is really concerning here. They then send those to they then have human epidemiologists who review it, check it, and then use their own domain knowledge to say, like in this particular case, the actual title of the article was SARS-like viral pneumonia outbreak of SARS-like viral pneumonia of unknown origin. You don't get more serious than that. And then they overlay it against transportation corridors. So again, we only look at what's in the news media. We don't extrapolate beyond that. What they do there, which is really interesting, is they take that and they superimpose that on things like transportation corridors. So they're able to then say, we show, our data shows there's an outbreak here. They flag that and say, yeah, this isn't just small. This is going to be really severe. But then they're able to pinpoint the fact that Wuhan is a major transportation corridor. It's got, it's a huge industrial city, flights all over the world. This outbreak can go viral. So the following day, on December 31st, 2019, they sent out a worldwide alert saying that, this is going to be a big deal. So that was a really, really powerful kind of story there, the power of translation. So you think about it, this starts off with, we monitor some local news media in a place that nobody's looking for a disease outbreak at that moment. We machine translate that, we geocode that, we do all these different annotations, enough that a machine learning model is able to take those annotations, flag that, hey, this is serious, and then a worldwide alert sent, a matter of hours later. So that's kind of a really powerful thing, especially with geography. In 2015, again, with geography, I did a really interesting piece for Foreign Policy magazine, mapping out global wildlife crime. So the time period, what I was wondering is, we talk about like how often is wildlife crime? Wildlife crime can be, elephant ivory, poaching, illegal trade of animal products. It can be trade of live animals. And I talked to a lot of wildlife groups and said, this stuff just doesn't get covered in the news media. It's not worth looking for. Well, it turns out I made this map, and this map had a dot across it's actually really sad that it did this, but there was a dot basically everywhere on Earth. There was location. And it was an interactive map. You could click anywhere on planet Earth, and you'd see what was happening there. What was so fascinating about this is almost all of that coverage was local outlets in local languages. So again, the importance of multilingual geocoding to be able to go through, like in the Donetsk Republic, which again is that area of Ukraine where the civil war was or still is at that point. It was able to show 2 people were ticketed for illegal fishing. So again, that's a really interesting story. In the middle of a civil war, this happened. It captures, again, all these local things that are happening around the world. It really reminds us of just how much we're missing by only looking in English. So again, that geography, that international piece of that.
So situations like that where somebody told you, well, the illicit animal situations don't happen very often. It doesn't get covered. Well, it happens locally, but it just doesn't get shared from a global or national perspective where people, it's kind of undervalued or under recognized, would you say?
That's the thing, is that obviously governments report some of these statistics, but it's kind of haphazard, all that data exchange. But when it comes to news media, yes, the New York Times, it doesn't cover elephant poaching unless it's some huge, story. But every day things happen on planet Earth, and local media are reporting these things every single day. So again, it's that importance of looking locally, which really requires these adaptations to really be able to look locally. And we also then take the imagery out of each of these articles. We run that through their Google's cloud AI tools. So for still images, for video, and of course for speech. And for imagery, it does attempt to estimate the location. So it looks through that image and it says, if it's obviously a random street corner, it's not going to be able to do much. Well, let's say it's a picture, in a particular notable area, it's going to be able to estimate and say, hey, I'm pretty sure this image was taken at this particular location. That's a really powerful thing. We also scan all the imagery we see in news articles. We do scan for EXIF embedded metadata. So that's where you can embed, metadata. So if you have a camera that embeds GPS coordinates, again, we're only looking at professional news imagery. But it's interesting. You do see some news imagery that is georeferenced, some that, most is not. But again, looking for any source of location that can help us kind of make sense of the world. And I should add, with that wildlife one, that was a clickable interactive map. And so for us, so you can imagine the stuff comes in, we translate as necessary. And then we basically extract out all the locations we found in that text. Now, what do you do with that? Well, many different things. Obviously, we do custom code that does different types of geospatial explorations. But BigQuery, which is Google's database platform, it supports GIS natively. And so we can load in, literally billions and billions and billions and billions of extracted points. And with a simple SQL query, you can instantly do geospatial analysis with that. To visualize that, like in terms of like pipelines, we use BigQuery to do a lot of geospatial visualization, or a lot of geospatial analysis there. For visualization, for beautiful maps, we tend to use something called Carto. They have this one, I've been using them way since back in the day. They have this beautiful interactive map, mobile compliant and all that. And then and that's a great one because it has a BigQuery connector. So you can literally just say, I want to map all the locations that mention quarantine and violations from news media, and a single SQL query, and instantly you have this clickable map you can drill in. And again, that's not quarantine violations, that's locations affiliated with it. So it could be a reference to there's a violation here, or it could be, gee, how come we're not seeing violations here? So we use Carta for that visualization. And then for some of our very, very large maps where we need to, we're putting billions and billions of points on there, we'll use GraphViz to do software rendering if we have very specific needs there, especially geospatially situated network diagrams. We do some things with Gephi too if we're doing geospatial networks. So if you think about it, data comes in, BigQuery where we do our analysis. For visualization, it's Carto for interactive maps. It's a Gephi if we need to do really beautiful publication-ready geospatial networks, or that GraphViz if we need these really, really massive kinds of maps.
Awesome. And CartoDB has been able to handle all that from a map visualization at scale for all the demands that you needed?
Yeah, so Carto is really interesting. For those that haven't used it, it's a really, really powerful platform, actually. You can just drop in shape files and Excel files, have geospatial stuff. It'll just magically put it on the map. Unlike other types of tools, if like you have a shape file that has a problem, you don't get oops, I'm sorry, I can't load this. It just figures it out and loads it for you. So it's really, really user simple.
I was a big user of Google Fusion tables before CartoDB kind of, I want to say replaced it in some sense, but kind of took it on when the deprecation of Fusion tables went away. And I use a lot of Fusion tables within Google Drive to process, and we'll call it the poor man's geo database in some ways, but to quickly aggregate and share and distribute with folks who didn't understand a lot of coding or a lot of development tools on the side. So.
Well, and one of the big things from Carto too is the ability to do these interactive maps that work well on mobile devices. So when I make a map, it works great on my desktop, it works great on my workstation, and most importantly, it works great on my mobile phone when I'm in a low bandwidth situation. The other thing with Carto that we rely on very heavily is something called Torque. It's what it used to be called. I don't know what they call it now, but it's basically their animated maps. So one of the really, really interesting things about Carto is when you want to do animated maps, so time series of maps. So like one of them, we had a map of all the locations mentioned in American books, U.S. public domain books have been digitized as part of the Internet Archive and the Library of Congress and the other digitalization projects. We did this big project. We extracted all the locations, make this wonderful map. So now you've got, 120-year map basically down, and you have got all these points. You got a couple million points in that map. There aren't many tools. Like usually you'd render that out as a static YouTube video and just have that up there, but then you can't zoom in. Carto, it loads all those things in memory on your phone. And so you have this interactive map, you can see everything. But then what gets really, really interesting then is because it's dynamic, this is all, this isn't a pre-rendered movie, this is dynamic. I can actually zoom all the way in. So I can say, so show me all the references to places in Washington, D.C. And I can see it, or I can zoom all the way out. So again, the really powerful elements, because I think that's an underappreciated part of geo is, how much of geographic visualization historically has been pre-rendered, rasterized, whether it's still images or movies, versus today, like the fact that we can do all this in real time, it's mobile compliant. And for us, again, that pipeline of the geocoding gives us those locations. So, data comes in, we translate as necessary, we do that geocoding. But then you have to do analysis at scale. You have to, and then be able to visualize this stuff or allow interactive exploration with the data. And you have this range of people. For GDELT, for GDELT, we've got everyone from GIS specialists who, they just want the coordinate data and they'll go to town on it. You got people that are in these incredibly advanced neural models that actually do, deep learning, reasoning over geography, extract out patterns and such, on through, journalists and others that are not geospatial people. They just want to be able to make a clickable map to see if there's any interesting geospatial patterns there. So again, like supporting this wide range of users has always been a really fascinating area of just how different the end user needs of geospatial are, and how you can support that basically.
No, so you bring up two different points that I like. One is, let's start with, you just finished off with your types of users, right? Who would you ideally like to see using GDELT in the data? You obviously have a wide range of individuals, but who's the intended use of it? Who do you like seeing use it? And who would you like to see take advantage of it at the end of the day?
Yeah, one of the biggest user communities is NGOs that are, trying to understand, things. And that to me is a really interesting community because it spans, some of the biggest household name NGOs. They have vast geospatial data science teams that live and breathe this stuff daily. So they just need, you hand them a couple trillion lat long coordinates and they can go to town on it. But then, some of the most interesting things are the local NGOs, like especially in the NGO space. Again, a lot's dominated by those household names. But when you get down to the local level, that's where change occurs. A major NGO based, say, here in DC, they're important, but they're not really having an impact on the ground directly. That's through their subsidiaries. It's the people on the ground. And to me, the really exciting part is local groups, like these local, whether it's an NGO, whether it's an activist, whether it's a journalist on the ground, how can they use this data to answer really, really crucial questions to their respective communities? And this is a really interesting question because especially journalists, they're not, again, as a practicing journalist myself, it's a really hard, especially the time pressure of journalism. You don't have time to fire up a big geospatial analysis tool. Like you need results fast. And there's not, most journalists are not trained in geospatial. They're not trained to even think spatially. So how do you assist with that? And an interesting area too is like, especially in the NGO community, people that are geospatial, they tend to kind of specialize in precise coordinates, like GPS tag data. So it's a really interesting thing when you try to merge GPS tag data with the world, with the realm of textual space, which tends to be in the form of centroids. In our particular world. So this becomes a very interesting one.
So you talked about a couple tools, a couple like the graph database, et cetera, but are there tools that you're developing or do you have on hand to help, we'll call it, non-geospatially trained journalists and things to just quickly plug into the data and quickly understand a quick snapshot of what's going on without having a lot of, having a developer or a third party kind of grab all this data on the side?
Absolutely. So we have actually something called summary.gdeltproject.org. So just literally summary.gdeltproject.org. And that will take you to our interactive explorer. So that has several things, Television Explorer and others. But one of those is our online news search engine that goes back to the start of 2017. Very soon it will go much further back. But as that, you can type in a set of keywords and you can search the full text of the machine translations we've generated from all this. And one of the options you can ask for is a map. Now, the map is only limited to a 7-day window right now, and that's purely a technical resourcing issue. But then what we'll do is on the fly, we will generate a map of the top 1,000 locations most commonly associated with the keyword that you referenced. So we have that. You can use that interactively. You can see if there's interesting clustering there, for example. But then we have a bunch of other tools. Typically, again, right now, it requires a lot of computational skill to work with the data. We will be launching later this spring a new analysis site that will include a whole range of mapping tools where literally you'll be able to come along, type in your things, click go, and it'll dispatch it outward to a cluster. And a few hours later, you'll get your results emailed to you with a nice, beautiful map, maybe some spatial analysis. So you'll be able to say, for example, I want a clickable map, or I want an animated map, or I want just a still image for publication, or I want a geospatial network, or I want geospatial statistics computed on this. So we'll have a range of these things. You'll type it in and go. And that's going to be, I think, a huge leap forward to really kind of democratizing the ability to do really advanced analysis. Because we've kind of reached the point now where we have the data. One of the challenges is, when you have many, many trillions of data points in a single data set, it's kind of, again, like, how do we make it easier to work with that? Especially in areas like geography, where it's not as, not every computer, computers don't come equipped. Every Windows box comes with Paintbrush. Every Mac comes with something basic. Geography, not every computer comes equipped with that. It's a different skill set. So how do we make that easy so you can really start leveraging the power of space?
Absolutely. No, especially when things like Google Earth seems to be slowly fading into the wind, and then people are relying more on web applications now. And then all you're left with is expensive tools from Esri or other applications, right? So,
and especially, again, it's also the learning curve of, it's most people, they don't need all these spatial statistics. What they want is they just want, like, a typical use case for us is, I just want to make a clickable map of all the places in the last 6 months that have been associated with elephant ivory seizures. Mm-hmm. All very simple case. I just want a clickable map. That's a typical use case. So how do we enable that and allow you to customize that and embed that within other things? And so that's, again, like, less is more. Like, most of our user community, they want the simple, the very simple pieces of that. And again, integration with things, whether it's Google Maps, whether it's, Google Earth fly-throughs, whatever it is. Again, they want integration with these things so that they can, use the platforms that they're, essentially bring the data to whatever they're most comfortable with, essentially.
Excellent. So this comes in a little bit differently. You've talked about some of the data sources, such as media sources and TV, and even dived into radio a little bit. But for, is there a plan to integrate sensor data like imagery, AIS, ADS-B, RF signals, things like that that could actually validate or even enhance some of the validity of what's going on in terms of events that you're detecting globally?
Yeah, so in terms of GDELT really it focuses on news media because, again, sensor data is already natively geographic. There's already many different ways to get to acquire geographic data. Whether it's ship tracking data, whether it's different types.
And let me clarify. A lot of the sensor data lacks narrative and context, and so you almost have the complete opposite problem on the other side of the spectrum. Yeah, you get the exact locations, but you lack any type of story or understanding the activity from the other side. You, of course, on the other flip side, where you're dealing with, you got all the context, but you don't have any of the locations or connecting the dots between where this stuff's actually happening, right? So I always see like two polar opposites trying to figure out how to bring them together more.
Yeah. So like I was saying with GDELT, we focus on news media. Essentially, what we focus on is creating the annotations that don't exist. We say, sensor-based data exists. It's readily accessible. It lacks certain things, but as a data analyst, if you're interested in, say, overlaying, say, weather with conflict data, see if there's a link there, and there's a lot of research in that space. Weather data is accessible. It can be very, there's a lot of nuance. There's a lot of other things that go with that, but it's accessible. If you want that, that data of like where are protests occurring, where are governments, attacking their civilians, that data doesn't exist. So we focus on really creating the data that doesn't exist. And that's kind of our sort of boundary point, is creating that data and letting you do the analysis. I will add that there are groups that are doing this thing. So there are a number of groups that are using things like GDELT in concert with temperature data, that are using GDELT in concert with other types of sensor-based data. There are some really interesting groups that are taking satellite imagery, overlaying that with GDELT and comparing those. So there is a lot of work in that space. We don't do that because that's kind of our focus is really on the news media. But yes, there are a lot of people doing that type of sort of ground truthing, where you look at, sensor-based data tells you the what. It doesn't tell you the why. For us, we have the why and we have, the semi-precise where. So again, it's kind of marrying those two of the ground truth versus what's being reported. And I will add, of interest with imagery, that's another area that we've been looking a lot at, is because we extract all the imagery that's in these articles and we're analyzing more and more of that. If an article says, boy, there was this huge flood that totally wiped out downtown today, the text, what does that mean, wiped out? The imagery that is ground truth. So we can show from that, because we do a reverse image search, we can say, hey, this imagery that accompanies this article, this has never been seen before. So this is brand new, novel imagery. And, based on that, yeah, this is a flood line. It's going past the roofs. This is a huge flood data. So now you have sort of the text giving the context. You have the imagery as sort of a potential ground truth. And now you can then overlay that with other types of data, like satellite imagery could tell you, again, a photograph of downtown is narrow. Satellite imagery could give you kind of the broader context of how far they're spread. And then other types of sensor data, like flow data, could add additional context to that.
Well, and I'm also thinking that, you say you extract the images from the articles, perhaps, maps that are locally made based off of, hey, we manually mapped out where the boundaries of this disaster took place. How do you annotate that for people who've never seen it before? That's unique in itself, right? And that's not even dealing with necessarily the imagery, but just outlining where the locals know where the damage was, right? So
yeah, and you can actually filter. So you could actually filter our data and ask for, find me imagery that appears to be a map. So you can see, find me imagery that appears to be aerial photography, find me imagery that appears to be satellite imagery, find me imagery that appears to be a map. So you can filter that, and you can say, find me imagery in articles about this flood that appears to be a map. So yes, you can do that. Now, again, that's not telling you that could just be a classic, stock image of, here's a map of a country where the flood's occurring. But again, there's a lot of, dimensions to that.
Excellent. No, appreciate answering that question. One more before we start to wrap up here is how much, you're pulling in so much data. How much data are we talking about that you hold in GTEL's archives? Are we talking about petabytes of information here? How much have you accumulated for how much you've collected over the years?
Yeah, the last time I tallied this actually was mid-2018. And at that point, it was about 3.5 trillion data points. And it's grown orders of magnitude since then. So I haven't even tallied it recently. It's huge. I know that. So like for our mapping data set. So again, you can keyword search these machine translations and get a 7-day window, and that's all 65 translated languages. We do have a geospatial data set separate from that, a downloadable data set that goes back to about 2016, English only, where we actually give you, here's each location and kind of a brief little snippet around that location. So that is like 1 billion plus or so location entries in that. And that gives you, again, location, latitude, longitude, country, codes, et cetera, et cetera. So, again, even small data sets are very massive in these scales. And also, again, you think about, you have the raw data set, like a raw data set, like the knowledge graph might be, here's an article, here's the locations we found, here's the emotions we found. every year I produce a map of global happiness from that. So there I take those geographic data points. So you have one row, maybe there's 10 locations found in this article. The average tone was whatever. And then I tally that to each of these locations. So now again, you're magnifying the amount of data from that. And what I do there is I say, take last year, every reference to Paris, France last year, what was the average tone of all of those references? And what you get are these really fascinating maps that don't reflect how people, it's not the happiness of people at that location. It's how the world portrays that location. So you see these really fascinating things about how the world just assumes everything over here is doom and gloom and war and famine and horrible things. Everything over here is wonderful and cheery and innovation and brilliant and wonderful. And you see these really fascinating things. And of course, you can drill down. You can say, how is the media of a particular country focusing, on the world or portraying the world? It's these really fascinating things. We don't realize just how much our understanding of the world around us is framed. So I do have a daily version. We can actually watch the days. It's like raindrops, red and green raindrops, kind of seeing global emotions. But what gets really interesting, things like the refugee crisis in Europe, you can see green, green, green. And you can see these intense negative tendrils, which are the refugee pathways through Europe, as the local media start turning against the refugees, as economic issues across Europe start having economic stumbles. You need a scapegoat. So you actually see all this again by looking at this sort of 30,000 foot view. You really see these fascinating patterns in there.
Oh, absolutely. That's incredible. Actually, just to get precise, to watch the migration movements of immigrants. That to me has some huge interest because I used to try to track that with satellite imagery. But to know that you can do that through news and local media is quite incredible, especially for trying to handle news that may not be as I guess maybe there's this stereotype that looking at local regions like Africa or more disconnected areas in the Middle East, you might not be able to get as precise because the internet is not as connected over there, right? But perhaps that's not even the case, right? It's more connected than ever. And you tell me, how accurate can you get in the more of those remote locations?
Well, this is what's interesting is, we kind of have this, because again, very few people in the U.S. read media from other countries. It's a fascinating thing. I mean, you look at especially political science, where they still haven't really recognized that you need to look beyond, U.S.-based sources. There's a famous terrorism data set. Its entire catalog of Islamic State terrorism events were cataloged from a couple of U.S., like the Chicago Tribune, a couple of U.S. English language newspapers. It's like, that's not a great way to catalog something occurring on the other side of the world. But they say, well, we can't. We don't have anyone that speaks these languages that reads these sources. So, this is something that I think very few people realize, like when you actually, like again, having Estonian heritage, where Estonia, you have a lot of English language media there. People don't realize, they don't realize when you actually look at local, especially when as you travel around the world, you pick up local papers, you learn a little bit of language, you have a translator with you, and you realize just how much is missing, and even if all you do is look at the pictures in the paper, it's pretty clear. So we find there's actually a lot of geographic detail. There's really rich. In fact, our greatest challenge for local media is that geography is too rich. So like a local outlet in, say, a rural area somewhere, will reference local locations where, it's like it'll reference a particular hill. It'll say, Large Top Hill. That doesn't appear on any map anywhere. What is that? So you end up with these hyper-local gazetteers where you have to do there's a lot of interesting challenges there, but even named locations, because again, local papers are designed for local people that know everything in their local area. You don't need to clarify. Like when I used to live in Illinois, Champaign and Urbana are two cities side by side. You didn't need to talk about, when you said Urbana, you didn't need to say Urbana in Illinois in the United States right next to Champaign. Just if you mention Urbana, everybody knows it's Urbana because the newspaper's local. So this is an interesting challenge and that's why we try to estimate the location of each outlet. It's a real challenge for us, especially if you have, say, like take Syria. A lot of news outlets in Syria, a lot of them are dissident run, where the actual server may be, say, hosted a data center in the U.S. The chief publisher and a lot of the key reporters may, whose names appear in the bylines, may actually be based in the UK. The outlet might be registered, say, in France. And reporters may actually be on the ground in Syria. So you have this really complicated thing of like, where do I put that geographically? And so we do a lot of what we try to do for outlets is estimate what is the location that this outlet focus on the most, we assign as its potential likely location in the absence of any other data. But yeah, it's a fascinating thing. What we find really is that location, there is really rich location across the world. It's just if you have to look for it, basically. It's just, read the local outlets in the local languages, and you have the details. Actually, it's too rich, essentially. And that poses some very unique challenges, but it's certainly not the other direction where, you lack for geography.
No, I appreciate clearing that up. I think there's this massive misconception of there just this knowledge gap there, and there really isn't. It's just we fail to look at what's available locally in other languages, just like you said. So from a perspective of wrapping this up, what's ahead for GDELT, and where would you like to see it go next over the next couple of years?
Yeah, so obviously, it's a huge focus right now is on, how do we make this data more accessible? So today, what we do is we have some APIs, and we have lots and lots and lots and lots of massive data sets for download. And what we want to be able to do is kind of close that gap where, if you just want to look at some narrow little slice of that, there's not an easy way right now to do that. So that's without technical skills. So this is something we're working on right now is, again, rolling out these new analysis tools where, say you're a journalist and you just want to map one little area, you can do that. Just click a few buttons and it's done for you. So that's a huge, and even for data science, something we've learned, for example, cartographers, they may be really, really good with GIS tools, not so great with downloading a geo data set with a couple billion points in it. So again, even for the geosciences community, helping to kind of, aggregate and reduce the data, kind of give them those narrow slices that they can work with. So that's a huge area. Looking at new types of being able to analyze this. So, again, it's one thing to say, here's a map of all the locations being associated with, say, disease or vaccine access right now. What we want to be able to do is ask, are there things that I'm not even noticing in this data? So that's a big area of kind of looking through that data, kind of sifting out the unusual patterns in that data. So that's a huge area we're very interested in, especially how neural models can really start kind of reaching through that. And then constantly looking at new types of way we can understand content. So something we're very interested in right now is something we're prototyping something that we call right now the global relationship graph, which is right now in our data, we do have events, but that's a very narrow kind of taxonomy. And otherwise it's more of, saying that this article talked about this. What we want to be able to do is let's say, for example, that an article says, that there was an outbreak of Ebola at this particular location. But then other coverage says, no, there was not an outbreak there. What we'd love to be able to do is codify the world in sufficient detail that we can actually say, hey, there's a contradiction here. This says this says this, there's a contradiction there. What we want to be able to do is autonomously identify those contradictions linguistically, geographically, across those different dimensions. So again, you can imagine right now we focus on producing this fire hose of data. Moving forward, it's about how do we make that data more accessible? And also things like geography. Right now, you can map things, but how do we allow spatial reasoning? How do we allow you to take our different data sets and look at these different types of spatial patterns or network patterns, combine modalities, networks in space, be able to look at all these different things, be able to look at contradictions, like identify the patterns in that data autonomously before you even knew to look there. These are all, I think, really, really huge focal areas moving forward. Leveraging the fact that technology is there is really about how do we harness that into something that's user-friendly for the world.
Absolutely. No, this is an incredible endeavor that you're working on, and it's fascinating to hear once again how it started and just the level of effort. Because honestly, the web pages they're very descriptive, but I think it significantly underplays the amount of effort that's gone into it and what it can be really done with the data that you can pull from it. It's incredible. So with that said, I thank you for joining us, Kalev, and one of these days, maybe coming up when you have a new product release or an update with exactly what we were just talking about, helping journalism get their hands on geospatial data in a much more user-friendly way. I'd love to have you on again down the road. This has been an amazing story, and I think even from my perspective, I've messed with GDELT a few times over the years, but just scratching the surface of what kind of powerful tool it is. And I'm not even sure, I know a lot of folks in the industry are aware of it, but I'm not even sure they realize the value that they can truly pull out of it, even from a local level, regurgitating it from even analyzing their own neighborhoods or even local cities of what's going on.
Well, thanks. Yeah, thanks so much for having me. And again, everything's open data. You can just go to www.gdelt project.org. So just www.gdeltproject.org, gdeltproject.org. All the data sets are there. The blog, there's also blog.gdelt project. And that, it's daily. Every day we post something up there, either an analysis or a data set or a code sample. So again, it's all open data, and just, go to town with it, do exciting things with it. And, if you have something really interesting to do with it, send me an email. I love to feature things on the blog about it. And so, yeah, I'm just excited to see, So thanks so much for having me. And I'm just excited to see what people can do with it.
Awesome. Well, thank you very much once again for joining us. I'm Adam Simmons with Project Geospatial, here with Kalev Litaro with the GDELT project. And we'll talk to everybody next time. Thank you very much, everyone.